Basics of Carnot cycle. Kelvin Planck statement of second. No process is possible whose sole result is heat flow Q out of reservoir at a single temperature and the performance of a work W equal to magnitude to Q. In effect, this statement of the second law says that it is impossible for our generalized engine to look this. Heat supplied Q and output is equivalent to W. It is same because this represents a perfect engine with 100% efficiency. The Carnot cycle, given that an interesting question to ask is, if we put all engineering and practice a issue aside, with what is the most efficient engine that you can make as far as physics is concerned. In 1824, a French engineer, Carnot, becomes interested in this question. The result was a theoretical engine called the Carnot engine that operates in a cycle consisting of two isothermal processes and two adiabatic processes, as well as we will soon see and analyze in detail. What is remarkable about this engine is that it represents the most efficient engine possible because it is a perfectly reversible cycle. Unfortunately, a practical engine, the Carnot engine, rather useless. Actually, it's impossible to get it to work at all because any real processes is not perfectly reversible. Still, on paper, at least, this is the most efficient engine you can possibly make, which make it very useful. Still, on paper, at least, this is the most efficient engine you can possibly make. Carnot realized this, and this led to what is known as a Carnot theorem. No real heat engines operating between two energy reservoirs can be more efficient than a Carnot engine operating between the same two reservoirs. The corollary of a Carnot theorem is that all Carnot engines working between reservoirs at the same temperature have the same efficiency. Note that I have put the reversible in brackets in the statements because although Carnot originally referred to Carnot engines in this work, calculus later showed that any reversible cycles is composed of finite number of Carnot cycles. Now we will see the 4 steps of the Carnot cycle. The Carnot cycle consists of two reservoirs, a hot reservoir at TH and a cold reservoir at TC, and a piston and cylinder consisting of ideal gas. The cylinder is made from same magnetical material, is a perfect insulator during the adiabatic processes and an excellent heat conductor during the isothermal process. The alternative is the piston is always an insulator, in which case we do the adiabatic processes very quickly, but the isothermal processes take nearly forever. Now we will see the PV cycles for Carnot cycle. The first process from A to B is an isothermal expansion TH with the piston in thermal contact with the hot reservoir. During the expansion, the gas absorbs heat QH from the hot reservoirs and does the work WAB in raising the piston. Process BC. In an adiabatic expansion, so no heat enters or leaves the system. During the expansion, the internal energy changes and temperature of the gas decreases from TH to TC. The gas does work WBC in raising the piston. Process C to D is an isothermal compression at TC with a piston in thermal contact with the cold reservoir. During the compression, the gas expels heat QC to the cold reservoir and work WCD is done on the gas through the piston. Process D to A is an adiabatic process, so no heat enters or leaves the system. During the compression, the internal energy changes and the temperature of the gas decreases from TC to TH. work WDA is done on the gas through the piston. Now we see the efficiency of a Carnot cycle. The efficiency of Carnot cycle is given by formula 1 minus Tc upon Th. This is the key result because the efficiency of Carnot engine has nothing to do with engine itself, nor how much heat flow in or out of it, nor how much work is done. The efficiency depends entirely on the temperature of the two reservoirs that the Carnot engine is attached to, that's all. The higher the temperature difference, the higher the efficiency. If Tc is equal to Th, then C is equal to 0, our engine stops working. This is not the case for reversible engine because E is small than Ec. These are the basics of Carnot cycle. Thank you.